Hi, good morning to everyone. Today I am Muaz and I am here to present to you our experiment group. Basic measurement experiment 1.1 about length, volume and density. Here I am not doing this alone. I am here with my other teammate which is Zaid Haris and Muizuddin, which you will learn about them later in the video. Okay, so let's move on to the next slide. Our first slide is about the objective of this experiment. In this experiment, we have two objectives, which is the first one to determine the volume and density of ball bearing, and the second one to determine the volume and density of glass block. So here we can see that we are using a few apparatus such as vernier caliper, micrometer screw gauge, weighting scale, ball bearing, and glass block. Here is the example of vernier caliper. We can see each of the item and how to use them. On the next image, we can see micrometer screw gauge. Okay, now from now on, I will pass on to my teammate to let them give a chance to perform in this video.
Hi, I'm Zai. I'm going to continue with the procedure. First, a micrometer screw gauge. First, the zero error is to be determined. Second, the diameter of the ball bearing is to be measured. Note, the ratchet knot is to be turned until a click sound here. The ratchet knot should not be overtuned as this would cause damage to the micrometer. Number three is step two is to be repeat at least 3 times at different position of the ball bearing. Uh, Number four is all data is to be record in a suitable table. And lastly is the actual diameter reading is to be calculated, taking into consideration the zero error obtained early. Okay, for number six is the weight of the ball bearing is to be determined. Number seven is the density of the ball bearing is to be calculated. B is a vernier caliper. First, the whole number of small divisions on the fixed part of the caliper that are to the left of the zero mark on the vernier is to be count. This provide the size of the object to the nearest whole millimeter. Second, the first mark on the vernier that align with one of the mark on the fixed part of the caliper is to be found. The value of the mark on the vernier then indicates how many fraction of a millimeter are needed to complete the estimate of the size of the object. Number three is the zero error of the vernier caliper is to be determined. And the leg width and thickness of the glass block are to be measured. The vernier caliper, and the first step two is to be repeat at least 3 times at a different position of block. Six, all data is to be record in a suitable table. And number seven, the actual measurement is to be calculated, taking into consideration the zero error obtained yearly. Number eight, the weight of the glass block is to be determined. And number nine is the density of the glass block is to be calculated. So this is the result. First, to measure the diameter of the ball bearing using a micrometer screw gauge and to determine its volume, the formula to calculate the value V is V equals 4 over 3 pi R. V equals to 4 over 3 pi R cube. So the zero error equal negative 0.03. Okay, this is the table. There is observed reading diameter of the ball bearing in millimeter, radius ball bearing in millimeter too. Okay, for the first attempt, we get 20 millimeter, and the radius of the ball bearing is 10 millimeter. For the second attempt is the same until the third attempt. That's all same with the first attempt. For the average is 20 millimeter, and the radius of ball bearing is 10 millimeter. Okay, for the true reading, first attempt, we get 19.97, and for the radius of ball bearing is 9.985 millimeter. The second attempt and the third attempt is the same, uh, and the average is uh, you must uh, uh, okay, to find the average is you must uh, plus with the three attempt and divide by 2, and you will get 19.97, and for the radius of the ball bearing you will get 9.985. Okay, for the next part is I will go through with uh pass with to my friend. Okay.
Okay, my name is Muhammad Muhyiddin. I'm going to continue presentations. The results to be measured the length, width, and height of the graph block using the linear caliper and to determine its the volume. The formula to calculate the V equal length multiply width multiply height. 0 equal 0.00. So this is our observed reading from first intake until third intake. Uh, we continue the length. Uh, all the all the length from first and until third intake is same 11.45. We continue with which first intake is 1.90. The second intake is 1.90. The third intake is 1.89 higher. First intake is 6.2. Second 6.2. Third 6.21. For the average, we calculate all the results and divide by 3. So the average of length is 11.45, which is 1.9, high 6.2. Result data sheet of about true reading. First intake is uh, the length also the same until second and third intake. Weight first intake is 1.9, second intake is 1.9, third intake is 1.89, and the higher first intake is 1.2, second intake is 1.2, third intake is 1.21. So we continue for to calculate average. We calculate all the numbers and divide by 3. The average of length is 11.45 with 1.9 high 1.2. We continue to next slides. We continue the next slide is analysis. First, calculate the value and the uncertainty of the ball bearing. The answer is 20.47 mm per cube. The uncertainty, the glass block is 1.05 cm cubes. Second analysis, calculate the distance and the sensitivity of the ball bearing and the glass block is the answer 4.42 multiply 10 power negative 5 gram milliliter cube. The uncertainty of the glass block is 0.02 gram milliliter cube.
Hi, see you again, and I'm here to talk about discussion and conclusion. So, in this discussion, the lab report and basic measurement covering length, volume, and density engage us in a true exploration of fundamental scientific principle. We delve into meticulous technique for measuring length using vernier caliper and determine volume to precious laboratory practice, recognizing the importance of addressing zero error of accuracy. Our report guide us to the meticulous process of recording data and calculating actual measurement, integrating theory with practical application. Furthermore, our discussion and turn to the determination of density, emphasizing the significance of this measurement in scientific analysis. We highlight the repetitive nature of experiment for reliability and the sense in the sci- in and the systematic recording of data in table. Through this, we gain not only practical skill in laboratory process but also deeper understanding of the theoretical underpinning of basic. Overall, our lab report serves as an essential education tool fostering a holistic approach to scientific measurement technique. So, in conclusion, our experiment aimed to determine the volume and density of the ball bearing electrically and systematically. In summary, our investigation aimed to precisely determine the volume and density of the glass block. Through meticulous measurement and calculation, we gain valuable insight into its physical property and characteristic. Okay, for me, let's see our next. So this is our reference. If you want to check out, then you can check it out on our slide. And that's all from us. Thank you for everything. See you again. See you soon. Goodbye.